In this example, we are going to use both linear approximation and differentials to estimate cosine of 31.5 degrees. In part A, we are going to use a linear approximation to estimate this value. And then in part B, we'll use differentials. Over here in this green box, I've put down our formulas. Our function is going to be approximated by L of x, and then I have the formula for L of x. Our function f of x is cosine x, and this is approximated by L of x. L of x is equal to f at a plus f prime at a times x minus a. X is always the value that we're given, and in this example, x is going to be 31.5 degrees. And then a is a nearby point, or in this case, an angle, with a known cosine value. The value of cosine that we know that is close to 31.5 degrees is 30 degrees. Now what we need to find is f of a and f prime at a. F at a is cosine of 30 degrees, and that is root 3 over 2. Now we need to find f prime at a, so we first have to find f prime of x. F of x is cosine, so f prime is minus sine x. And then we can find f prime at a is minus sine of 30 degrees. And this is minus 1/2. I'm going to highlight f of a and f prime of a because we're going to need to plug those in. We can now write down L of x. So L of x is f of a, which is root 3 over 2, plus f prime of a, which is minus 1/2, and we multiply that by x minus 30 degrees. Now we want to find L at 31.5 degrees. So this is root 3 over 2 minus 1/2. 31.5 degrees minus 30 degrees. Now here's where students usually get confused. We cannot have degrees in our answer. Instead, we need to work with radians. So we have to multiply this by pi over 180 degrees. This answer then is equal to 0.852935. So we can say that cosine of 31.5 degrees is approximately 0.852935. I want to show you how good this approximation actually is. So I went ahead and I took my calculator and I plugged in cosine 31.5 degrees. And here's what I got, 0.85264. So our approximation is really good. Now we're going to do the same thing, except now we are going to use differentials to estimate cosine 31.5 degrees. When we use differentials, the notation is very different than when we used linearization. For differentials, we are going to be approximating f at x plus delta x, and I've written down the formulas for that approximation. We're going to start by saying that f at x plus delta x is cosine of x plus delta x, and this is going to be approximately, looking over here at the right at our formulas, f of x plus dy. And if we substitute in what dy is, this approximation is f of x plus f prime at x dx. X plus delta x is going to be the angle that we're given, and that is 31.5 degrees. And then x is a nearby angle with a known cosine value, and that is going to be 30 degrees. What we need to do now is we need to find f of x and f prime at x. Since f of x plus delta x is cosine x plus delta x, f of x is cosine x, and x is 30 degrees, so this is cosine 30 degrees, which is the square root of 3 over 2. Now let's find f prime at x. That is going to be minus sine x, and x again is 30 degrees, so this is minus sine 30 degrees, which is minus 1/2. And then I also realized that we also have to find dx. dx is the same as delta x, so that is going to be 31.5 degrees minus 30 degrees, which is 1.5 degrees. Now we're going to take all three of these values and substitute it in to our equation. So we can say that cosine of 31.5 degrees is approximately f of x, which is root 3 over 2, plus the derivative minus 1/2 times dx, which is 1.5 degrees. And then we need to convert degrees to radians, so we multiply by pi over 180 degrees. And we get the value 0.852935. And that, of course, is the same value that we got when we used linearization.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.